안녕하세요 여러분, 혜리입니다. So in this video we're going to finish the vector syllabus for SL students. So we're going to start with scalar product, or it's also called as dot product. So we're trying a multiplication, kind of a multiplication of vectors. So let's say we have two vectors like this in a component form, and a dot b. So this one is not just that multiplication, so it's a big dot, thicker dot, okay? So this a dot b is defined as a1 times b1. This is a multiplication, so we multiply x by x, y by y, and z by z, okay? So plus a2 times b2 plus a3 times b3, okay? And we can also define the dot product as the magnitude of a times the magnitude of b times cosine theta, where this theta is the angle between vector A and B. Then some may wonder, what does it mean by the dot product? So it's very hard to tell just using mathematics. So this is the definition of dot product. But if I use some physics knowledge, then I can make a better explanation. So for those students who don't take physics, sorry, you may not be able to understand. So we know that energy or work done equals to the force times the distance or displacement, right? So we all know that the force and the displacement are both vector quantity, right? So that means if you have a certain vector form of force and displacement, then we can compute the work done by their dot product, because I'll tell you why. So let's say we have an object like this. So we have a rope connected to it. So let's say you're pulling the rope, okay? So that you have pulled this, and let's say you moved it to here, all right? Then we know that this is the displacement, right, as in vector, and this is the force applied, right, as in vector. So we know that work done equals to the product of force and the displacement, but note that this force is not the horizontal force, right? So we have to compute the horizontal force. And how do we do it? We can create a right angle triangle, and we can say that this angle between this force and the displacement is theta. Then the horizontal force would be so this would be the trigonometric ratio, right? So cosine is the adjacent over hypotenuse. So if we call adjacent as the horizontal force, then we have this equation, right? So that means we have the horizontal force as in the force, magnitude of the force, force applied times cosine theta, right? And what about displacement? So the magnitude of the displacement will be just this, right? So that means the work done here we can calculate by multiplying the displacement with the force applied. So we can write this as force dot displacement. Okay, and note that energy, so in the beginning I said that energy is a scalar factor, right? So note that, not scalar factor, scalar quantity. So please note that the the output of scalar product or dot product gives you scalar. So that's why it's called the scalar product, okay? And for HO students, later you will learn something called the cross product. So that one will give you vector. But yeah, that's the story for the next video. So yeah, so that's how you can kind of understand what scalar product is. Okay, so scalar product is again just trying to multiply vectors. So what can we do with scalar products? So as you can see, we can have either this or this, and we know that these two are the same, right? That means if we rearrange this, we can find the angle of the vector, angle between two vectors. So rearranging this, cosine theta is simply a1 times b1 plus a2 times b2 plus a3 times b3 over this. And if you take arc cosine on both sides, then you can find the angle, okay? So that's how we can find the angle between two vectors. And with scalar product, there are some basic properties that we have to know. So first thing is that when you have a dot b, it's the same as b dot a. So this is called the commutative law. So you don't have to know the word. So just note that if you switch them, it's the same, like multiplication or addition, okay? And for the proof, you can simply prove it using any vector in this. So let A be that, B be that, and then just compare the left hand side and the right hand side, and you'll see that they will equal to each other. So the second property that you have to know is that when you have a scalar multiplied to this, then you can move that scalar factor anywhere. Okay, so yeah, this is just saying that you can move the scalar anywhere, okay? Third, so when we have a vector, when we have to dot a vector into another vector where that another vector is an addition of two vectors, then the distributive law is satisfied. So this is called the distributive law. So yeah, there are a lot of things that we can do. And one last thing, very important. So when you dot a vector by itself, then using the definition of scalar product, it will give you the magnitude of A times the magnitude of A times the angle between them, right? But what's the angle between the vector by itself? It's 0, right? Then what's cosine 0? Cosine 0 is 1. It's not 0, right? Cosine 0 is 1. So we have this. Okay, so when you dot a vector by itself, you get its magnitude squared, okay? And this is gonna be very, very useful when you handle some scalar product related questions, okay? So let's try some examples, and then yeah, I'll tell you why this is very useful, okay? So let's say the magnitude of A is 1, the magnitude of B is 2, and A dot B equals to 2, and we want to find the magnitude of this vector. Alright, so we don't know any of the components of A and B, right? We only know the magnitude, right? And we only know their scalar product. Then how do we do this? So for this, what you can do is that first you consider the square of it. Why? Because using this, so a vector magnitude of a vector squared that means you can write that as a dot product of itself. So the vector here is 2a plus 3b. So it's this entire thing as one vector. That means we can write this as this. And we have seen that the distributive law works, right? So we can just expand it out as what we know. So 4 times a dot a plus 6 times a dot b and 6 times b dot a, and lastly 9 times b dot b. Okay? What's a dot a? A magnitude squared, right? And from the commutative law, so we know that the commutative law is satisfied. So we have a commutative law for vectors, scalar products. So that means a dot b and b dot a are the same, right? So that's just simply 12a dot b. And we have 9b dot b, that means 9 times the magnitude of b squared. And what's magnitude of a? 1, right? So that's 4. A dot b is 2, so that's 24. And magnitude of b is 2, so magnitude of b squared would be 4, so 36. So we will have 64. That means, so now we square root it. And when you square root it, note that we have plus and minus 8, but we can reject negative 8 because magnitude, right? Magnitude cannot be negative, so we reject negative 8 and accept 8. Okay, so 8 should be the answer. So please be aware that when you square root, you will have plus and minus value, okay? And then after that, you either reject a value or accept both values for certain circumstances, okay? So let's try another example. So this time we have magnitude of A and magnitude of B. And let's say the angle between A and B is 60 degrees. So find the angle between A plus B and negative A plus 2B. Okay? Oops. So that's the solution. So yeah, let's try to find the angle between that. So that means in order to find the angle, so we need to do the dot product, right? So that means, so remember, when we have a constant, we can just move it everywhere, right? So we can make it like this. So when we have a constant, we can make it outside. So that means we just put minus there and then a dot a for the first thing, okay? And the second thing, we have 2a dot b. And then again, that's minus a dot b because of the commutative law. B dot a and a dot b are the same. And lastly, we have 2 times b dot b. Alright, so minus a dot a is this, right? And this one we have a dot b. And this one we have plus 2 b dot b, so this squared, right? Then what is this value? This value is -1. And then, okay, let's so keep this at the moment, and we have 2 here. What's a dot b? A dot b is very simple to calculate because we know the angle, right? A dot b is magnitude of a times magnitude of b times cosine 60 because their angle is 60. So what is this value? This is half, right? So that means negative half, so that's 1.5, so that's 3/2. But so then after this, what can we do? So don't remember that that's the what is the dot product, And we know that this dot product is also magnitude of a plus b, right, times magnitude of minus a plus 2b, right, times the angle, right, and that equals to 3 over 2. So now that means we have to find the magnitude of this and the magnitude of this, right? Then how do we find it? So again, doing the same thing as what we did here. So that's a plus b dot a plus b. So that means modulus of a squared plus 2a dot b plus modulus of b, magnitude of b squared. So I'll speed up a bit. So we have 1 plus, and we already know a dot b, right, which is, I'll just write it here, half, right? So 1 and then another 1, so we have 3, okay? Then what about negative a plus 2b? So it's just, and note that we have to square root it as well. So remember, we reject the negative value, so we have square root 3. And it's the same for this, so we have we consider negative a plus 2b magnitude squared, so that's negative a plus 2b dot negative a plus 2b. So we have magnitude a squared, and again I'll boost it up a bit so you guys can try slowly by yourself if you can't follow quickly. So that's 1, and we have negative 2, and that's 4. So again we have 3. So the magnitude of this is also root 3, right? So that means, where is it? So yeah, so that's root 3 and that's root 3, right? So that's 3. Then cosine theta is half. Cosine theta equals to half, right? So root 3 and root 3 and root 3. So theta must be pi over 3. Okay, 60 degrees. So, or you can write it as in degree, because the question gives question is in degree, so yeah, maybe we should write in degree. So 60 degree. Okay, so that's how we can answer the question. So you can see that this last property is used a lot. Okay, for more like, so I have actually considered some like difficult example for SL. For HO it should be fine, but yeah, for SL it's a bit difficult. So I'm going to try the easy examples for like finding the angle, the simple thing. But I'm not gonna do this here. I'm going to do this when we learn the equation of a vector. So equation of a line in a vector form first. So, as already hinted just now, we're going to start with equation of a vector. So basically we're trying to find the equation of a line. So okay, equation of a line in a vector form. So yeah, the form that we're going to learn now is called the vector form. So far we've learned the component form, right? Base vector form, and now the vector form, just the vector form, okay? So what is it? So let's say we want to find a line passing point A and has a direction of AB. So let's say we have a point A here and point B here. So this is the line that we want to find. So let's say the origin is here, so we have two position vector as A and B, okay? So again, what we are trying to find is the equation of the line, right? So that means every value on this line. Why? So y is this line because, well, it's containing a, right? And it has a direction of AB, right? So that means we want to find the line, the equation of every point here. So what we can try to think is that let's just make a point here called as R, and then this position vector of R, the point R, would be this. Then how can we write this in vector form? So you can so if we know the ratio, we can use the tip that I talked about in the last video. But unfortunately, we don't have the ratio, right? So we can't really use it. So what we can do is that, so we know that this R can be written as OA plus AR, right? So we want to find OR, right? Because that's how we can find every point on this line, right? So we want to find OR. And OR is in fact OA plus AR, right? So OA is simple, OA is just A. Then what's AR? AR is a vector parallel to AB, right? Then remember that if two vectors are parallel, then we can write it as A equals to a constant times another, where T is can be any real number. Then why don't we apply the same thing? So AR is parallel to AB, right? And what's AB? AB is OB minus OA, so B minus A. So AR is parallel to B minus A, so let's use constant lambda. So lambda can be any constant. And that's it. So we don't have to rearrange this. And what we can, so writing nicely, we have R, the position vector of any point on the line, it become A plus lambda D. So this D refers to the direction vector. And this A is any point on the line. Okay, so like what we, so assuming that you guys have done calculus already, okay, let's forget, no, so don't think about calculus. So imagine, let's recall how we can find the equation of a straight line, so a linear function. Okay, linear function, very simple, right? So what do we need? We need to find the gradient and a point on the line, right? So it's the same thing. So we are looking for the equation of a line, right? So instead of gradient, we need a direction vector. And we need a point on the line. That's it. So very similar, right? So yeah, that's the vector form. So this is the vector form of a vector, of a line. And and whenever you write an equation of a line like this, you always have to put this condition as well. So lambda can be anything. So some may wonder that, so this line has a direction of AB, right? And so that it seems like we started from A and then it's going that way, right? So then how can we include these points? So here lambda, as I said, it can be anything, right? So lambda can be negative value. Then if it's negative, so it's the opposite direction of AB, right? Which means BA, so it will contain all these points as well, okay? So yeah, this is the vector form of a line. And let's try some examples. So find the equation of a line in a vector form which passes point 1, -2, 3 and is parallel to a line so I hope that everyone can see it. So yeah, my handwriting is not that good. So it's 362, okay? And 1, -1. 1, -1, and 1. So this is a line, right? So equation of a line in a vector form. So that's the point on this line, and that should be the direction vector. So we know the direction vector of L1, which is 362. So for solution, so we want to find the equation of a line, right? So that means we need a point and we need a direction vector. And the point is already given, right? So the question already said that this point is on the line, right? Because the line passes through the point. Then what about the direction vector? So note that this line that we want to find is parallel to this line. That means their direction vector must be the same. So very simple, right? The equation of a line that we are trying to find has a point and then has a direction vector. Then can we use the same lambda? Just in case, use the other variable. Okay, so that's it. Very, very simple, right? Then let's try an example that is a bit harder than this. So this one is just way too simple. So let's try, so a line. Okay, the line. Alright, seems like I don't have enough space, so I'll just write it here. So the line L1 passes through the points 2, 3, 4 and 4, 2, 3. Okay, and the line L2 passes through the points 3, -1 and 2 and 1, 1, -1. So find the equation of L1 and L2 in vector form and find the intersection point. Okay, so that's the question. So like what we did just now, so in order to find the equation of a line, what do we need? We need a point. Any point is fine, and we need a direction, right? So the line L1 passes through these 2 points, so the point is already given, but the thing is we don't know the direction vector, right? So some may not be able to catch this directly, so let's try to think like this. So we want to find a line that passes through these 2 points, right? Then what do you think the direction vector is? Just a subtraction of these 2, right? Right, so let's call this as A and B. Then somewhere there must be an origin, right? So that means we can use AB as the direction vector, right? Because that's the direction that contains these 2 points. And also in order to find AB, that means we just simply subtract B by A, because AB is OB minus OA. Or you can also use BA, so OA minus OB, up to you. So that means the direction vector for line 1 would be 4, 2, 3 minus 2, 3, 4. So I always like the positive value on the x component, so I'll use this minus this, okay? So we have 2, -1, and -1. So we have direction vector already. That means the equation of line 1 should be R. So this means the position, right? So position vector, right? So that should be, so I'll use the point A. Doesn't matter which point you use. So as long as it lies on the line, you may use any point. So plus lambda 2 minus 1 minus 1 and lambda belongs to a real number. So that's it for the first one. And doing a very similar thing for the second one. So we can find the direction vector directly by subtracting the two vectors. So again, the order doesn't really matter, because the reason why it doesn't matter is not because they have the same value. It's because we can either use AB as the direction vector or BA as the direction vector, because this lambda here will do the job. So lambda can be negative or lambda can be positive. So it may cancel the positive, the negative sign, and then make it into positive, or it may also put negative sign and then make it to negative. Okay, so yeah, doesn't matter. 2, -2, and 1. Oh, sorry, 3. 2 minus 1. So have I made any other mistake? Seems like it's fine. So that means the equation of L2 will be 3, -1, 2 plus, so we cannot use the same variable. So if you're really lazy, then you can just use lambda 1, but usually we use mu. So lambda and mu. So 2, -2, 3. So these two are the equations of vectors, equation of lines in a vector form. And we want to find the intersection point, right? So intersection point means x component, y component, and z component must be the same. Then how do we find that? So note that every position, so every point on L1 is described as this, right? So that means the position can also be written as 2 plus 2 lambda, 3 minus lambda, and 4 minus lambda as just one vector, right? Because, so this is a scalar, then we can just put in, right? So it's just addition of two vectors. So remember, we added by x by y, x, y by y, and z by z. So that's the result for the line 1. Then what about line 2? Well, it's the same. So 3 plus 2 mu, and -1 minus 2 mu, and 2 plus 3 mu. So in order to find the intersection, that means x, y, and z must be the same. So we have three equations with two variables. That means we have even more, we have an additional equation to find the value, right? So maybe we can try to, so you can either use your calculator, but I'm a person who doesn't use calculator a lot. I'm more used to the Korean syllabus, although I did IB, so I'll resist to use the calculator. But yeah, it's absolutely fine to use calculator, to be honest. But anyway, so what we can do is that we can do some Gaussian elimination. So adding these two up, we have lambda equals to -3. Because if we add them, then we can cancel out 2 mu directly. And we can also multiply 3 here and multiply 2 here. Okay, multiply 3 here and multiply 2 here and then add up. So here we have 3. So -3 lambda and -2 lambda, right? So -5 lambda equals 2. So we multiply 3 here, so -12, right? And then we multiply 2 here, so it's -4. So that's -12, -4. That's -16. Oops, no. Oh, okay, sorry, never mind. So we have two variables with, okay, sorry, yeah. So we have lambda equals to -3, right? So that means mu must equal to, so by substituting the value, we will have, so 3 and then -1, so -12, right? So seems like it works for, so we have used these two, so we can check. So we put -3, so that's -6, right? And then, wait a second, why doesn't, oops, wait. Oh, sorry. So it should be plus 3, so negative 7. So negative 7 over 2. Yeah. So we can check. So lambda equals to negative 3, so negative 6, and then plus negative 6 and plus 7, so it's 1, and then plus 3 and negative 7, it's negative 4, right? But what about this one? 3 plus 21, right? And this time I didn't make mistake, so it's supposed to be like this. So that means the third equation is not satisfied, right? Then what does that mean? That means these two lines doesn't have an intersection. So in other words, we call this case as they are skew. So they are skew lines. Skew line means they don't have intersection. Then seems like they have intersection, right? So x and y works. X and y has an intersection, but it's the fact that they have different z values. So what does that mean? So you have a vector here, and you have a vector up here. So when you see it like this, it seems like it's it has an intersection here, right? But in fact, they don't. So this is what it means. Okay, so these lines, we call them skew. Okay, so we have a case where the intersection does not exist. So you should never stop at these two with these two equations. Okay, you have to continue checking with the last equation as well in order to determine whether a vector, the two lines are skew or not. Okay. Alright, and let's try one more example. This last example is simpler than that. So that's how we can find the intersection. And we want to, so coming back to the angle that I told you. So we're going to try an example using for finding the angle. So this should be the example 3. So find the acute angle between and yeah, so don't forget to write this. Okay, so lambda and lambda belongs to real number and k belongs to real number too. So yeah, we want to find the acute angle between these two lines. So let's quickly see the lines. So we have L1 here and we have L2 here, right? Then this is what we want to find, right? Then how can we find it? So note that the direction vector of L1 is this, right? So this one has this direction, and this one has this direction. Then do we really have to pay attention to the points? No, we just need the direction vectors. So basically, what we need to do is the dot product of the two direction vectors. So we know the scalar product, right? It's component by component. So 1 times 1 plus 2 times negative 4, which is negative 8, plus negative 2 times 1, which is negative 2. So we have negative 9. And we can also find the dot product by finding the magnitude. So that one should be root 1 plus 4 plus 4 times root 1 plus 16 plus 1 times cosine theta, where that's the theta. So that should be 3 because it's 9, and that's 18, so that means 3 root 2. So we have 9 root, and times cosine theta. So we have 9 root 2 cosine theta. So that means 9 root 2 cosine theta equals to negative 9. So that means cosine 9 equals to this. Then what does it mean? Theta equals to 135 degrees, right? So using the symmetry, if you don't know, then you can quickly sketch the graph and see. So cosine is negative, so it must be here, right? But we are looking for the angle, so it must be below less than 180, right? So it must be this. But what's this value? So this one is negative 1 over root 2. Then what about 1 over root 2? That's 45 degree, right? So using the symmetry, we have 180 minus 45, so we have 135 degree. But we want the acute angle, right? So that means that's 135. Then theta must be 45. Okay, done. Simple, right? So we are almost done. So one last, not example, but one last application with a bit of kinematics. So sometimes you'll have a question with vectors about like a motion of something. So a motion of a boat or a motion of a particle, and it may tell you the starting point and it will tell you the velocity, and then you have to use vector to solve it. So they will ask you to find the equation of the displacement, so their position of the object. Then how do you do it? So don't panic. So this R here that we learned before, it's basically telling you the position of all the points, right? Then position is displacement. So I assume that we have done calculus maybe. So yeah, if you don't understand this, then you can see calculus later. So displacement is position, okay? So that means we have a starting point, and then velocity is the direction. Then we should have a constant, right? A constant like this. And what's t? T is the time. Then why do we have to multiply t with velocity? If you recall the basic kinematics formula, so we have velocity equals to displacement over time, right? That means displacement equals to velocity times time. That's why we have these two components. So from here, this is a starting point, right? Starting point. And this will give you how much the object has moved within t seconds, or like t time, okay? So 3 seconds or like 5 seconds or etc. Okay, so an example, I couldn't really prepare make up an example by myself for this, so you may try past paper. So I note that I can't really solve the past paper question here because because of the copyright. So I'll tell you the question. So SL paper 1, May 2017, time zone 2, question 9 has a question about this application. So you can try that question, and then you can also check the answer using the mark scheme, okay? So that's it for IBSL vector. So you guys are done, but please be note that you will have a bit more application with this. So for example, you have a vector here, and then you have a point, and then you want to find a point on this vector, a line, such that these two are perpendicular. So this is actually a bit more complicated question example. So I'm going to include this example in the sample test. So I'll make up some questions by myself, and then you guys can try it, and I'll also attach the detailed solution. So don't worry about how to answer such questions like this, okay? So that's it for today. And for HL students, I'll see you in the next video for HL vectors. So we have a lot more forms and a lot more things to do. So vector product, and some other forms. So see you guys in the next video. Bye.